So far we discussed questions related to dice. Now let's discuss question related to playing cards. You must have played with this so far, I hope, in life. So playing cards. First of all, let's understand how many types of cards are there. Okay. So in cards, basically we can classify generally in red color and black color, right? So two colors are there. That is going to remain same for all the questions that we are going to discuss. Don't doubt that there will be something else, right? So red and black. Now these all shapes you will be able to see on the card. Those are called as suits. The spelling is S-U-I-T, suits, right? And there are 4 suits in the playing cards. The first is hearts, second is diamond, this one third is club, and fourth one is spade. Now when we see in the cards, there are total 13 cards are there in any suit. Remember, per suit there are 13 cards. How? First is ace, means in which there is A is written, right? It is 2, 3, 4, 5, 6, 7, 8, 9, 10, and at the end there is J, Q and K, means Jack, Queen and King, right? Now that variety is going to remain same along the suit, right? Either you take the diamond suit or you take club suit or spade. That variety is going to remain same. You will have ace, then 2 to 10 numbers, then Jack, Queen and King, right? It is, you need to understand this, right, properly, then only you will be able to see the probability. Now one more thing over here I mentioned already, that is face cards. Now face cards means what? On which there is a face is drawn. Now there are only 3 kind of cards which is present there on which face is drawn, that is Jack, Queen and King. Remember, ace is not a face card. Face card means we need to take the literal meaning of it, means on which there is a face is drawn. Face, if you can see face on that card, that will be the face card. But on the ace there is no face, so that is not a face card. Don't get confused. So overall, in the total cards, there are how many face cards are there? I think 3 4s are 12, right? 12 face cards are there. Okay, now we are interested in total number of outcomes. Why? Because we want to, obviously we find probability, we need total number of outcomes, then we get favorable outcomes based on the situation given in the question. So for that we need to find the total number of playing cards. How many playing cards are we having in this total? Let's count it. So see, there are 2 to 10, so 10, then okay, 10 total. If we consider ace as the 1, then 10, 11, 12, 13, 13 over here, same over here, here as well, and here. Now let's add them up. So we'll get what? 52. So there are 52 cards. Now remember, students get confused about over here that, sir, what to do with the joker? We are not going to consider joker over here unless it is mentioned somewhere in the question. Don't worry, those kind of questions are not coming. We'll only consider 52 is the total number of outcome for all the questions that we are going to discuss. If there is any kind of change is mentioned, right, we'll discuss that question as well, right? So basically there are it's classified in 2 ways, red and black. Then there are 4 suits, that is red is heart, then diamond, then club and spade. You have ace, then 2 to 10, then Jack, Queen and King. Remember, face cards, very important, where face is drawn, which is Jack, Queen and King. Now let's move on to the question. Let's discuss this question. A card is drawn from a well shuffled deck of playing cards. Find the probability of drawing a red face card. Okay, so first of all, let's clearly write just what we discussed. Total number of outcomes, very easy. So total outcomes are 52. Done. And we want to find probability of drawing red face card. Probability of red face card, that is question mark. This is what we are interested in. So let's take help of this one. We are interested in red only. So let's ignore this black part. Simple. Red. And what do we want in that one? Only face card. So in case of red, how many face cards are there? Okay, 1, 2, 3 and 4, 5, 6. So there are 6 outcomes are there, favorable outcomes. So simply let's write it. Favorable outcomes are how many? 6. We have total number of outcomes, then what are we waiting for? Okay, let's get the answer. So probability of red face card is equal to, what will it be? 6 over 52, right? You can, I think, divide it. Both of them are even number. Let's try. Here 3s are and here 26, and 26 is not present in table of 3. That's it. So this is our final answer then, 3 by 26, right? This is the very simple question. Remember what conditions are given? Red face card. So red only, ignore the black. Face card, only this part we are interested in. Count the number of cards and apply the formula and get the answer. Let's move on to the next question. Let's start with another question. Let's read the question. One card is drawn from a well shuffled deck of 52 cards. Find the probability of getting, first of all, a non-face card. Okay, so here one thing is clear. Total number of outcomes 52, right? So let's start with that only. Total outcomes are 52. Simple. Now what we are interested first is finding a non-face card. Probability of non-face card is equal to question mark. For that, first of all, we need to get the favorable outcomes. So let's write favorable outcomes. Favorable outcomes that we want to find. Okay, non-face card other than face card, right? So we know there are total 52 cards are there. Now what I'm going to do, I'll take first of all the face card. How many face cards are there? Right, 3 here and there are 4 suits. 3 4s are 12. Right, so if I remove 12 from all this total, I will be getting all these non-face cards, right? Okay, so how many total cards are there? 52. Simple. So 52 over here. And how many face cards are there? 12. So subtract 12 out of it. So you are going to get what? 0 and 4. So that is 40. Now directly let's go for the probability. We have the favorable outcome, that is 40, and total outcome, that is 52. So probability of getting non-face card, that is 40 by 52. Do the cancellation over here. I think we can use table of 4 here, I think, right? Yes, 4 10s are 4 13s are. So 10 by 13 is the probability. Simple, right? Non-face card we want, so you take all the face cards and remove out of it, which is subtraction. 52 minus 12, that is 40 favorable outcome. Now let's move to the next question. A black king, probability of finding a black king. Okay, let's do that one. So let's draw a line. Okay, probability of getting black king. Total outcome is going to remain same, 52. What we want to find is, let's give title, probability of black king is equal to question mark. For that we need favorable outcomes. Okay, favorable outcome, black king. We only need to look at the black only, right? Because we are only talking about black king. So black, there's 2 columns and K means king. So how many kings are there? 2 only, right? Don't go for 4 because that is the red column. We are only interested in the black one. So there are 2 black kings. So favorable outcomes are 2. Simple. Now let's go for the probability. So probability of getting a black king, let's write probability of getting black king is equal to favorable outcomes are 2 and total number of outcomes are going to remain same, that is 52. 2 ones are 2 26 are. So final answer is 1 over 26. Simple, right? First we discuss getting the probability of non-face card other than face card, this part, and black king, second one, only this two, very small part of it, right? So this is how we find the probability. Let's move on to the next question. Let's do one more question. A card is drawn at random from a well shuffled deck of 52 cards. Find the probability of getting neither a red nor a queen. Okay, so we are not supposed to get red card, not even queen, right? That's what meant by here. So first of all, let's get total number of outcomes. Total number of outcomes are 52, right? We can see over here, simple. Now, and we want to find the probability of neither red nor queen. Okay, neither a red nor a queen, question mark, right? This is what we want to find. Okay, so here we need to get the favorable outcome. That's the most important part, we know very well. Neither a red means we don't want to get the red card. So there are 52 cards and we are not going to talk about these two columns, right? So how many cards are left now? Out of 52 we have removed 26 cards, right? So let's write here favorable outcome, favorable outcomes. So we have 52 right now. Okay, we want to remove red card, so remove all the red cards. Done, that is 26. Okay, first condition is done. Let's move to the second condition, that is given nor a queen. We don't want queen as well. So see, there are 4 queens over here, right? In a deck of cards 4 queens are there, 2 in column of red, 2 in column of black. Now these 2 queens have been already removed. Be so precise over here, these 2 queens has been removed already. Now there are only 2 queens left from this black suits, so we need to remove these 2 queens as well. So -2 for the queen. First we removed the red cards, then we removed queen, right? Don't write 4 over there. Why? Because 2 queens have been already removed from this playing cards. So here 52 minus 28, so 12 here and 4. So 12 minus 8, that is 4, 4 minus 2, that is 24. So 24 is the favorable outcome and total outcomes are 52. Simple. So let's get the probability. So probability of neither a red nor a queen is equal to favorable outcomes are 24 and total outcomes are 52. No change in that one. Now I think table of 4 again here, 6 4s are and 4 13s are. So the final answer is 6 by 13, right? Simple. Let's repeat one more time. So here condition was given neither a red card, we don't want red card, so we'll remove all the red cards. Total we have 52. Remove means subtraction, 26 cards have been removed. Then nor a queen, we want to remove queen as well. Now remember one thing over here, that 2 queens has been removed already, so only these 2 queens are left. For that -2, now subtract it and get your favorable outcomes, that is 24. So favorable outcome over total number of outcome, that is 24 by 52. So final answer is 6 by 13. Let's move to the next question. Let's talk about one very interesting case over here. While we discussed this basic idea of this playing cards, I told you that total number of cards are going to remain 52, right? But in this case, the question that we are going to discuss right now, total number of cards are being changed. Why and how? Okay, it depends on the question. I told you many times. If it is given that it is a deck of 52 cards, then we are not going to change it. But if it is mentioned something somewhere that you remove this number of cards, you remove all the ace, you remove all the red card, you remove all the club or maybe spade, right? In that case, total number of outcome or total number of cards will be changed, right? Let's read the question. All red face cards are removed from a pack of playing cards, right? Let's stop at the first sentence, right? All red face cards. Okay, so we are talking about red and face cards. I told you face cards means what? On which there is a face is drawn. So jack, queen and king. Jack, queen and king for the heart and for the diamond. So total number of outcomes. Very interesting over here. Total number of outcomes. Let's write here. Total outcomes. Generally we deal with the 52. So we need to remove 3 face cards from the hearts and 3 from the diamonds. We know very well. So 3 and 3, that will make 6. So we are removing basically 6 cards out of the deck of 52 playing cards. Simple. So 52 minus 6, that will give you what? I think 2 will go, so 4 and 46 will be there, right? So 46 is the total number of outcome or total number of playing cards that we are going to take one card randomly. Okay, done. So that was about the first sentence. Let's move on. The remaining cards are well shuffled and then a card is drawn at random from it. Then find the probability of getting a red card. Okay, first we need to find the probability of getting red card. Let's write probability of getting red card. Okay, so let's talk about favorable outcome. Red card we are going to talk about. Remember, this part we are not supposed to take it. This as well, right? So 10 here, 10 here, 10 and 10, 20. So we can mention here 10 plus 10. And what is the total number of outcome in this case? That is 46. So 20 over 46. You can do cancellation and you are going to get what? 10 by 23. So that's my first answer. Probability of getting a red card. Simple. Remember, most important part here, total number of outcomes are not 52 but 46. Let's move to the second one. We need to get the face card. Probability of getting the face card. Let's start with the face card. Probability of getting face card. For that, okay, how many face cards are there overall? That we need to count. Generally, we take 12 face cards. But remember, we have already removed 6 face cards here. So how many left? 12 minus 6, 6 only. Or you can count here as well, 3 and 3, 6. So we have 6 face cards and total number of outcome, that is 46 here. So let's do cancellation, 3 2s are and 3 23s are. So answer is 3 by 23. Simple. Done. Very easy. Remember what you have removed over here. That's the most important part. Let's move on to the next one. We need to find the probability a card of clubs. Okay, we need to get only probability of getting a card of club, right? Okay, so how many cards are there in clubs? This is the club, right? So I think everything is perfect. We have not removed anything from this one. We have removed red face card, right? This part only we have removed. This part is intact. This suit is intact basically. So 13 will be there, right? 13 is the favorable outcome and total number of outcome. Remember, don't write by mistake even 52. That is 46, right? we cannot do any cancellation because 46 is not coming in table of 13, right? So that's it. Now see, what is the most important part of this sum is this first step, total number of outcomes, right? We have removed all the face cards, all the red face card, 3 and 3, 6. So 52 minus 6, that is 46. Now we want to find the only red card. So remember, while you deal with the red thing, don't count this 6 people, right? 10 and 10, 20 by 46. Face card, again confusing, right? Even you need to use that knowledge again. You have 12 face card, but 6 you have removed. So what's left? 6 only, 6 by 46. And then it is a club. Now there's no, relation between what we have removed because it is red colored and club is of black color. So this suit is intact, 13 by 46. So this is how we do the sums when particular number of cards are removed from the deck of 52. Let's talk about one more case. Let's start with the question. One card is drawn from a well shuffled deck of 52 cards. Find the probability of getting a spade. So what is the probability of getting a spade? That's very simple. I think spade is over here. We have 13 spades here. Total number of outcomes. I think no change in outcomes. So 13 by 52. Simple. Right? The second case is very important. That's why we are discussing this question. Either a king or a black card. Right? We need to have king or black card. Okay, we'll discuss in detail. Let's start with the first one. So total number of outcome, that's the most important step we do at the start of the question. Is there anything anywhere it is mentioned that we need to remove few cards? I think no, it's not mentioned in the question, right? So total number of outcomes are going to remain unchanged, that is 52. So let's write total outcomes. Total outcomes are 52. Simple. Now probability of getting a spade, that we I think discussed orally as well. Let's write that part. Probability of getting a spade. So how many spades are there? There are 13. Okay. And how many total number of outcomes? 52. Okay, you just reduce it. 13 ones are, 13 fours are. So that is 1 by 4. Our first question is done. Second one is interesting one, right? So second one, we need to get the probability of either a king or black card. This is what important part is. Now how shall we get it? Right? Okay, we need to get the favorable outcome. Now let's divide this into two parts, right? We will get the favorable outcomes for a king and favorable outcome for black card, right? So what is the favorable outcome for kings, right? How many kings are there in a deck of 52? We know very well, 1 2 3 4, 4, right? Let me write one more thing over here. 2 red and 2 black. So 2 red plus 2 black card, right? I'll tell you the reason behind this. Next is a black card. How many black cards are there? 13 clubs and 13 spades. So 13 and 13, that will make 26 black cards. Now before you directly add, right, stop and just think over here. See this king, okay, you will be counting 2 times. Why? Because 1 2 3 4, right? And again we are counting. So this king is, black kings are coming 2 times. So here we will not be adding 2 plus 2 plus 26, but we are not going to add this to black kings. Reason behind that is we have already counted those kings in the suit of spade and suit of club, right? It's been already over here, right? So when I get the total number of outcomes, that is 2 plus 26, that is 28. Now you must be thinking that why am I adding over here, right? Because it is mentioned over here, it is OR. Whenever OR is given, we are supposed to add the outcomes, right? You get the outcome for a king, you get the outcome for the black card, and you add them. Remember one thing, you are not supposed to take this 2 plus 2 plus 26, right? If you take this 2 again, then it will be double counting for these 2 kings, right? Don't count twice. Okay, so let's go for the probability of getting a king or black card, right? That will be favorable outcomes. How many are there? 28. Total number of outcomes, I think no change in there, so 52, right? 52 over here. Table of 4, I think, yes, 4 7s are 4 13s are, so 7 by 13 is the outcome. That is the probability. Sorry. So let's recall one more time. The first part was very easy. Spade. How many spades are there? 13. How many outcomes? 52. 1 by 4th. Done. This is important part. Or part, whenever or is given. Either a king or a black card. So king there are 4, 2 red and 2 black. And black card there are 26. But the most important part is this king will be counted double if we just add normally, right? So ignore this 2b and only go with 2 plus 26, that is 28. Substitute the formula and get the answer. Let's talk about one very interesting question. Here we are not having deck of 52 cards, but we have selected cards from that. Okay, let's see. 5 cards, 10, jack, queen, king, ace of diamonds are well shuffled. First of all, let's start with the total number of outcomes. Are we going to have total number of outcomes as 52? No, we are not going to have 52. It's mentioned over here that we are taking 10. Okay, let's say 10. Then we are taking jack. Then we are taking queen. Then king. And finally ace. Okay, of which suit we are taking of diamond? So, right, we are taking these cards from the diamond. Okay, this is our total number of outcomes are there. Remember, not 52, right? So 1 2 3 4 5 outcomes. So let's write total outcomes are 5. What is the probability to get the queen? Let's write over here, probability of getting queen is question mark. Okay, so this is very simple one, but the basic idea is to get the total number of outcomes. If you take 52, you are going to get all the incorrect answers, right? So how many times queen is coming over here? One time only, right? So favorable outcome is 1 and total number of outcomes are what? 5. So 1 upon 5 is the answer. Simple. So let's get ahead with that. Favorable outcome is 1, total number of outcomes are 5, so 1 upon 5 is the answer. So that was the first part. Let's move to the second part. Now second part, if queen is put aside, so in this case queen need to be removed, put aside, then find the probability of second card drawn is ace. Okay, so we are not supposed to take the queen. Now how many total number of outcomes are there? See, 1 2 3 and 4. Don't take 5 like we took in previous case, because we are not taking queen into consideration. So let's write total outcomes is equal to 4. Previously it was 5, right? Now what we want to find the probability of, that is of ace. So let's write probability of getting ace. Okay, so how many times ace is coming? Simple, 1 time. So favorable outcome is 1 and total number of outcomes, not 5, remember it's 4 in this case. So 1 upon 4, right? Very simple. The question is very simple, but if you start in the correct way, then it will look very easy. If you take the total number of outcome as 52, then your both answers will be wrong, right? Because total number of outcomes are different in both of the cases, right? So this was the topic about how to deal with the problems related to playing cards, deck of 52 cards.